Hi and welcome back to AATV Live. I'm your host Tom Anvil Hibberd, and today we're going to talk all about how your airsoft guns are made. So just for YouTube, let's just remember that these are airsoft replicas and not real firearms at all. I'm joined today by Ben Skinner, the English Kiwi, who's just sipping on his weak lemon drink.
Oh yeah, this amazing, very strong alcohol content lemon squash.
So Ben, how's your quarantine haircut going?
Well, you know, shaggy as usual. That's me, unkempt. But I mean, I wasn't for 3 months, so I'm all good here.
Cool. I'm just gonna. What am I having today? I'm gonna have a New England IPA.
Oh, tasty.
So just before we get going, and then we'll get going. So the plan today, guys, we're going to run through a kind of brief synopsis of how airsoft guns are made. Talk mainly about the kind of key processes, one by one. If you have any questions, pop up. Ben's going to keep an eye on Facebook. I'm going to keep an eye on YouTube. This is our first simultaneous stream, so welcome to the Facebook people and welcome to the YouTube people. So let us know if you can see us on Facebook. That'll be awesome. I believe we're live. Okay, Ben. So let's have a tiny bit about you. But let's talk about more of your kind of professional qualifications.
Well, in this area, I have none. I'm an electronic engineer by trade, so I'm good at designing circuits and pissing about with tiny little components that make your phones work. But I also have an interest personally in doing kind of hardware design. So I am, where is it? I am bringing out my own product at some point. Coronavirus pending. So I know a bit about what kind of goes into manufacture, although mine's quite high end because it's all CNC machines, so we can go into that in a bit.
Okay, cool. Well, that will definitely come up. So Ben, you're a little bit crackly, so I don't know. Not sure.
Am I crackly?
Yeah.
Hang on, let me try my.
Might be my end.
Move my mic, or it could be my internet connection. Not sure.
How's the sound on the stream, guys? Is it okay? Just before we crack on, could just be my my headphones because they're plugged into a port. Cool. Okay. So Ben. So you're an electronics engineer.
Yep.
I am. So let's just bring up the presentation, which you won't really see on screen for a minute or two, Ben. So this is how it's made: airsoft materials and manufacture. So a little bit about me. I'm a degree qualified product design engineer. I spent 16 years in the industry. I was in my previous life the senior product designer at Games Workshop in the kind of hobby products division. That team was responsible for kind of the tools, cases, paints, glues, scenery, and retail point of sale. So I had quite big experience with all sorts of different materials and manufacturing and techniques, and I've also got quite a lot of experience of manufacturing in the Far East. So that's designing in the UK and sending stuff. I'll just increase Ben's volume a little bit. So designing in the UK and sending stuff for Far East manufacturing, so China, Taiwan, and the rest of it. So
that sounds pretty high on the qualifications list for giving this presentation.
Well, I'm not an automotive or an aerospace or engineer of that sort. So in those terms, I'm not massively qualified. I have experience of designing stuff, and I have experience of having stuff manufactured, and I have experience of QCing that stuff and selling it to retail stores. But I'm certainly not a very good engineer in those terms, So, but okay. So let's crack on then. So the first thing we're going to talk about is injection molding, Ben.
Oh, injection molding! What a beautiful bit of manufacturing work there. So you kind of think of injection molding, you think of plastics.
Yeah.
But you can kind of do it with metal, although I think that.
Well, we're going to go into that in a little bit. Specifically, what we're going to talk about here is polymer injection molding. So injecting molten materials into a mold cavity. This is normally done with thermoplastic or thermoset polymers. So the difference between a thermoplastic and a thermoset is effectively you can regrind a thermoplastic and stick it back through the process again. So that's most of the stuff you have on your airsoft guns. Thermoset polymers, once they're moulded, that's it, they're stuck. And if you try and reheat them or regrind them, they'll degrade and they'll rot and turn into horrible stuff. Okay, the mould is. I'll show you a video in just a second, just to illustrate all of this. The mould is normally made from very high spec hard tool steel, or for lower run stuff, aluminium. This is the most common way of creating polymer parts, and it's really good for creating very high volumes of the same object. So if I come back to Ben and me, and I get up my airsoft replica, so that all the plastic parts or polymer parts on this are made from injection mouldings. So the upper and lower casings on the PEC-15, the two sides of this Magpul AFG, and the back end of this stock. Okay.
And depending on the kind of like quality of finish, you can normally find the actual kind of like inlet point for the molten plastic.
So you normally find what's called a gate, which is where the plastic goes in. You'll often find little sprue marks where they cut the sprue off. The sprue is how the plastic gets to separate bits of the mould. In general, ironically, good airsoft parts are better spec'd than real firearms parts. Because airsoft is moan about mould lines. And if you look at real firearms parts, generally there's mould lines all over them. It's quite one of those slightly mad things. Okay, I'll just try and queue up a video which will give you a quick presentation on injection moulding. There'll be no sound on it, but we'll kind of talk over the top. So,
cool.
So Ben, you might have to. It's going to be a bit delayed for you, but we should be. Yeah.
All right. My Facebook stream seems to have stopped, but I think that might be my internet as opposed to the stream itself. Let me try. Oh, yeah, no, we are still live. It's all good.
That's great. Okay, so this is this one I found on YouTube. It's a 3D animation of the injection moulding process, but it shows it quite nicely. So the red thing there is the plastic and gel polymer injection moulded part. There are loads of different plastics and polymers. We could go into it, but that'd be like a 45-minute stream all by itself.
Yep.
So the tool itself is made of two parts. You can see those. They both have the little brass plugs attached to them. That'll be for the water cooling, in order to cool the moulds to get the parts out quicker. So this is an injection moulding machine. You get granules of plastic go into the hopper. You can see the red granules falling down now. Ben's going to be really confused. It's going to be a bit delayed for him. And then you have a big, almost Archimedes screw, and that screw, as it moves, it's kind of fixed. As it moves along, it moves the granules of plastic along, and you have various heaters that gradually heat it until it's molten. It will just start doing that now. There we go. Now, once it's got enough material at the head of the screw, it forces the material into the mould under pressure. It will just do that now. Hopefully. Yeah, you can see the water cooling. The blue bits is the water cooling on the mould. You do get some moulds without it, but then they're only running in a few shots. So the mould's cooled, the screw retracts, the mould opens. In a lot of cases, it's ejected or it's then removed by a robot. In other cases, certainly in quite a lot in China, someone reaches into the moulds and takes it out.
So isn't this the same process for making BBs as well? They're injection moulded initially and then ground down to spheres.
Yeah, BBs are injection moulded. They come on a big sprue. So if you ever built a Games Workshop Space Marine, or you've built an Airfix or a modern airplane or a tank, those sprues are exactly the same. When you get BBs are made on sprues by I don't know how many, a lot, and that's how BBs are made as well.
It kind of reminds me, like I've seen the kind of like tray, this kind of like 30 centimetre by 30 centimetre tray of BBs. Kind of reminds me of like when you get a new battleship game and you have to poke out all your pegs. They look like the same sort of thing. So yeah, if you're in a pinch, you could probably make a BB out of some battleship hit marker pegs. Okay. Not that I'd recommend that.
So again, it comes in a granulated material. It's heated in a screw ram. When it's molten, a specific quantity of material is injected. The mould is cooled to set the material, and the part is ejected or removed from the mould. So that's pretty much mostly. There are some other techniques for making plastic polymer parts, but that's the most common. It's expensive. So good tooling is really expensive. 10 to hundreds of thousands of dollars. We spent a lot of money on Games Workshop on tools. I think one of the biggest ones was $500,000 for bottle caps, but that had all sorts of mad weird things that popped in and out and flexed and did all sorts of stuff. There are some issues you get. Again, we already talked about it. You get kind of part or split lines. You can get things like sink marks. So particularly where wall sections are too thick, and they get uneven cooling. You can see it quite a lot on plastic parts where it looks like there's a little bump in the surface. If the part is removed too quickly from the tool, you can get warpage. So we kind of all had that when you've kind of got big plastic parts and we're trying to stick them together, or even just like storage crates, and the lid's on the piss.
Yeah.
You can get uneven shrinkage. So things when they cool, they shrink. You tend to get between like 2 and 3% shrinkage out of a mold. So you need to design that in.
Yeah, it's the same with some types of 3D printing as well. So SLS printing, which is kind of a similar process. You take nylon powder and then heat it up so it molds together at molten points. But normally they have to overprint it by about 20%, so it will then shrink down to the right size.
Yeah, and to say you need to be things need to be well designed, and it's often things are not well designed for injection molding. You do get things like side cores. So particularly on this stock, the part of the tool will come in from this direction. The other half will come in from this direction, but there will also be 2 big fingers which have to go all the way down here. So that's a big side core to make more complex molding.
Yeah. So I was just thinking about, you're saying the price of molds.
Yeah.
I'm assuming that these kind of mags are injection molded for the casing. In fact, you can see the seam lines running down them.
Yeah.
But they're selling these at like £6 a go. So what do you think their tooling cost was?
I really don't know. It's all about how many you produce, what material you use, what the labour's like, how fast you cool it for. These things, generally the higher quality, you want to leave it in the mould to let it
for longer. So the slower the turnaround rate of
So then your cycle time goes up, which then increases the cost. Big fingers, yes, Ben. Big fingers. Okay, so that's injection molding. So that's really, really common. Not just in your airsoft gun, just everywhere. Injection molding.
Yeah,
and everything else as well. Okay, so let's move on. One of the things with injection molding is that it generally has poor mechanical properties. So that's why we don't see plastic gears in our guns and things like those lines. You could do. It was one of those things.
Well, Aries used to do. Didn't Aries used to do plastic gears? No, it was plastic gear boxes they did.
Okay, yeah, but Ben Webb on YouTube's made an interesting point. Most injection molded mags are pretty sloppy, and actually a lot of airsoft bits in general are quite sloppy. Hence the abundance of self-tapping screws, which is so part of that is self-tapping screws save a lot of money because you need less complicated tools because you can mold in threads and everything else into injection molding tools, but you need more complex tooling. So if you have a self-tapping screw, it means you don't need to start molding threads and all sorts of stuff in. So generally, it's just bad design and cheap tooling. Okay, so the next technique we're going to move on to is are you listening to yourself?
Sorry, the video's been shared onto Thin Brown Line. Their group is now group watching us.
Oh my god, terrifying!
I know.
Okay, so the next manufacturing technique, which is really common. Really common is die casting. So the reason I've put this after injection molding is it's pretty much the same process, but you're using molten metal instead of molten plastic. The way it goes in is a bit different. They tend to have a hopper and a big syringe almost, and then it gets injected in. This is most commonly used for like receivers and gearboxes, and it's normally used for non-ferrous metals. So we're talking about zincs, aluminium. You can do copper and a few other things as well. It's also very often used. Again, we'll go back to the airsoft replica example on the receiver of this movie. So the upper and lower receiver of this are die castings.
But not all die casts are equal, are they?
No, you can get some really naff ones. And it depends on, again, it's the same stuff we talked about with injection molding. Is it depends on the quality. The quality of the design.
Yeah.
How consistent the wall thicknesses are, how consistent the, have they put proper radiuses in? Are there any hard edges? It's also about the cycle time. It's about the quality of the alloy that they use for the casting.
Yeah.
And I'll show you. I've got a little example later in the presentation about why die casting isn't the best. If you run it too fast, you get a lot of bubbling. So you get little bubbles, internal bubbles inside the casting, and the crystal growth. So when it sets, the crystals can be really uneven. So the way the metal sets, again,
well, you can see that in some gearboxes. You can actually kind of like see the crystalline texture of it.
Yeah, it's really rough. It's really rough.
Yeah.
If you look at a cheap gearbox, and then you look at a something like a GMP, one of the old GMP gearboxes, they are superb in terms of how their consistency and how well they're made. As I think Mark's just pointed out, some die casting is terrible. Hence, people radius gearboxes. Why are people having to radius gearboxes?
Yeah, it should be something that should just be standard.
It's ridiculous. It's clearly something wrong. And also, die casting is really expensive. So these tools could be really, really old.
Yeah.
So the tooling used to make die casting could be really, really old.
Worn. But I mean, rounding corners is not something that is new. Like, this is what happened with the Comet aircraft. The first Comets that kept crashing was because they had square windows and they got metal fatigue in those corners and they'd crack, and the whole thing would, kind of fall apart in the air. And then they changed them to round windows, and like most airliners you see nowadays with rounded air windows, and suddenly that problem went away. And it's the same thing with gearboxes. Why have that right angle when you can just put a nice rad on it?
Yeah, absolutely. Again, I'm just going to run another YouTube video of some die casting, and I'll talk over the top. Hopefully this is coming out all right. Yeah. Okay, so die casting. So again, we've got the mold just like we had in the injection molding machine. And we've got a great big kind of crucible or furnace. That's the big green thing on the right hand side. I'm sure he's waffling on. Let me just. So you got a fixed die and a moving die, and a big furnace. So this animation will just show the cycle. So in that big white pot on the bottom right is in our case would be a load of molten. So generally in airsoft terms, it's molten a zinc aluminium alloy. There could be all sorts of weird stuff in there to help with flow, rate, and cooling, and everything, crystal forming, and everything else. But generally, it's some form of zinc aluminium alloy. So instead of heating granules, this time you just have a big molten bath. Opens an inlet, and this video is pretty good at showing how everything works. Might hurry it on a bit. Once it's got enough metal in, big ram forces the molten metal into the mold, and it comes out again. So it's very, very, very similar to what we've previously had on, to kind of injection molding wise. It's just you're using hot zinc instead of hot zinc aluminium alloy instead of anything else.
And in terms of airsoft, a lot of airsoft manufacturers won't do this process themselves. They will outsource this.
Yeah, I suspect a lot of gearboxes are made in the same place. A lot of AR receivers are made in the same place, and then they go out to different manufacturers. But again, because the tooling's really expensive. Yeah,
absolutely.
If it's not expensive, generally, and I've seen some pretty horrendous stuff in China, it's really, really dangerous. So you kind of pays your money, takes your choice really. Obviously, we don't want dangerous manufacturing practices, but it does happen out in the world. So that's die casting is in terms of how good a system it is. It's really not great. So molten metal's heated. You can have a hot chamber or cold chamber. Cold chamber is when the metal is heated externally and then put into the system, and a hot chamber is when the furnace is integral to the system. Then you have to cover it in lubricant, which doesn't help either. So you get the same problems with die castings as you get injection mouldings. You get part and split lines. You get a load of flash. A lot of us have opened gearboxes up and you see bits of flash and misalignment, and the two halves don't sit together properly because they've not filed off the bits. You get part warpage. Again, when you get uneven cooling, things twist and bend a little bit. Again, you need to get your shrinkage right. Again, it shrinks as it cools, and all these things need to be well designed. And I suspect a lot of airsoft stuff is now quite old, and they, really does need to be revised, but it just isn't.
Well, let's think about it. So, V2 gearbox came around the early 90s, or was it late 80s?
Yeah. So that tooling may well still be the same tooling
in use.
Yeah, and it gets tired. Tooling does wear out.
Yeah. So when they say, "Oh, this is TM spec," it's actually, "Oh yeah, we're just using the same cast as TM, just with crapper materials, probably." Or well, in some people's cases,
and they may well have taken. There's a way of die casting and casting where you use you basically take a direct cast, then you make a ceramic impression of the cast, and then you make a negative, which is in the metal, which is in tool metal. It's the way we used to do scenery at Games Workshop before we. Which is why none of the really old, going back 5-10 years, that's why none of the old Games Workshop scenery used to go together. Okay, so we're going to move on to MIM. So metal injection molding. Metal injection molding. I'll show you a picture in a minute. You most commonly see it in airsoft for really small parts and for gears. Often used for airsoft gears. It's exactly what it sounds. It's metal injection molding. So it's injection molding with metals. The way MIM works, Ben, is it's quite good for producing really complex shapes because you're injection molding stuff. Again, it's good for high quantities. You can use a variety of metals, and it can consolidate multiple processes. So for a complex part, which for another process you might need several different manufacturing methods in order to, and then have to combine it, you can just do it in one go.
Because I'm just trying to think about how you could make gears, and the kind of obvious answer is to turn them.
Yeah, so you CNC
can't
them.
Turn the teeth into it. You'd have to then find a way to cut the teeth onto your turn.
So Marui are die casting them.
Right.
You can either die casting in steel is not an option. So then you have to CNC them or you MIM them.
Yeah.
So there's a picture on screen for the stream at the moment, and those gear. It's really often used for spur gears on the pinion gears on the end of motors, because that's a really complex shape, and none of it's flat or square. The other stuff you can kind of CNC and combine. But and also bevel gears are quite often MIM'd as well. Again, because the shape's just a bit more. It's not like a bunch of flat stuff stuck together.
No, it's not.
There's angles and bits and bobs. You can see how it's more difficult to get a cutter in.
Yeah. I guess your sector and your spur are very much a case of you could just cut those kind of like almost like cake layers and then just pin it all together.
Yeah, if you look at the construction, it often is for CNC gear. They're often two layers and they're pinned together onto a common shaft. So with MIM, the machines are either the same or very similar to injection molding machine. I won't show you the process because the process is virtually identical. But what they do is they take a powdered metal and they mix it with a binding material. Now that can be a resin or a polymer or a wax or something else, and they granulate it. So it turns into a very similar way as they make coffee grinds and they make coffee granules. So they spray it into a vat and it consolidates, and then they put those granules. That stuff pretty much goes into an injection molding machine. It then gets injected into the mold and it comes out and cools, and it has all the same issues as a plastic part. What they then do is they then partially remove the binding material with another process, and that's quite often a big solvent bath and then a low temperature oven. So they get rid of all that plastic and it all vaporizes and disappears. And it then goes into a really hot oven to sinter. So since we're talking at 1200, 1300 degrees, because they want to pretty much not quite make it molten, but they need it all to consolidate and move back together again. There's massive shrinkage, so you're looking at 12 to 15%.
So you can do the same process now with 3D printers.
Yes.
So with FDM printers, you can now get filament loaded with metal that you print your design out at, I think it's like 150% scale, and then bake it, and it burns off the plastic part.
What you'll get then is what's called a brown part. So they have kind of they have a part that comes off the machine, and then it goes through that kind of process, and you get a brown part. Often because it looks quite brown because it's oxidized, and then it goes and then it goes into another, and then when it goes into the big sintering oven, which obviously you can't do at home unless you've got a forge. That's when it really consolidates. But yeah, you get a lot of shrinkage, 12 to 15%, or potentially more, and then it'll probably need post processing. So again, it will need another process in order to make it work.
Yeah,
it's really common on like lap kind of. It's not a massively precise until you kind of post-processed it, so it does have its own issues. It's expensive, right? Because it's a high volume process. You don't do it unless you're making a lot of things. It's not especially dimensionally accurate, though. It's pretty good. Some post-process machining is often needed. It's got a limited part size, so this doesn't normally impact airsoft because most of the parts are just about big enough. And it's not as strong as some other processes, but it's probably stronger than die casting. And because you can use steel. It's going to be a lot stronger than a zinc alloy. We may well get some MIM receivers at some point, but that's pushing the weight of how much you can do for a MIM. Probably not economic at the moment. It's pretty cool. It's pretty cool for making gears. It's pretty cool for making little complex little objects, and certainly higher stress stuff. But basically, you need to make a lot of them to make it economic.
Do you think like sight posts and stuff would be MIM?
Yeah, you could do stuff like these are probably cast, but you could MIM this sort of thing would be the front sight would be a really good candidate for MIM work. Maybe like little latch handles and bits of charging handles and stuff like that. You see it a lot on laptop hinges and glass hinges and stuff like that.
Yeah.
Where you need high strength. It's fundamentally for a complex part that needs to be really strong. That's the application.
Right. Okay.
Let's look at the comments. So Ben says recycling of material. Yeah, God knows what goes on. Whether they regrind stuff and chuck it in. And Jamie Fisher, it's worth noting, especially with electronic and gas products, some countries have different safety standards and import tariffs on certain items, which can affect. Absolutely. Let's not get into the import of certain airsoft guns, which probably aren't CE marked for electronic usage.
Yeah. Yeah, it's not.
So that's probably not the best thing to go through. Okay, so we're kind of rattling on, which is good because we want to get some questions out of you guys towards the end. So the next process we're going to talk about is... I've almost forgotten. Just check. Casting. Okay, now casting's a massive topic because there's a million and one ways of casting. But fundamentally, you're pouring metal into a cavity. Or you can pour anything. You can cast chocolate. You can cast urethanes. You can cast gold. You can cast... fundamentally, you're pouring a molten material into a cavity. But it's more of a pour, and you're looking at a fairly simple piece without massive complexity to it. It's very flexible in terms of material choice. You can cast anything you can melt. You can cast pretty much. It's relatively cheap and low tech. I mean, I don't know if we did some aluminium casting at my D&T class when I was at school.
Yeah, I remember doing that.
People are now casting with 3D printing, Ben, because they're doing. We'll talk about that in a minute. You can make big parts. They made tanks out of castings. Not tanks as in air tanks, as in battle tanks. World War II Sherman. The top of the Sherman in World War II was cast.
Yeah, the top. You can tell. Like if you look at most of those kind of era of tanks, and I think the Chieftain as well. You've got quite a boxy bottom.
Yeah, the Chieftain's
really been welded together, and then you just look at the top, and it's like this nice round.
Large bits of the Chieftain is cast. So this. Without wanting to bore everyone, there's kind of two main ways of casting. One is it's expendable versus non-expendable. So it's whether you basically have a permanent mould that you keep casting into, or you have an expendable mould which is destroyed every time, and you have to remake it every time you cast. Okay.
So yeah, when I did the casting at school, we used basically a model of what we wanted in aluminium, and then used sand.
Yeah.
That was your destroyable mould. So you'd press it into the sand, split the sand in two, take your part out, put the sandbox back together, and pour in your aluminium, and away you go.
Yeah, I mean it's a very accessible technology.
In fact,
people are doing it with PLA now, so they're using PLA to make destroyable moulds.
Let me have a quick look. So one of my colleagues at work actually runs a kind of a YouTube channel for this sort of stuff, where
Oh, cool.
he has all sorts of random bits and pieces of equipment, and I think he did do some. He bought a 3D printer to try and do cast molds with it. Just trying to remember which ones has it in. There we go. So if I
Full screen you. Hang on, if you get it running.
transition over and one.
Okay, cool. So he's 3D printed it on his 3D printer in a plastic filament, and then he's going to sand cast it effectively, or is he going to? He's doing a So he's
plaster of Paris.
Plaster of Paris mold. Okay.
Yeah.
So yeah, it's really casting's really. Actually, and people have been casting stuff since the dawn of time. They were casting bronze swords. They were casting gold. They were casting metals.
Yeah.
Okay, so went in the fire, it burnt out the plastic, and then he poured into it.
Yeah, by the looks of it.
Yeah.
That's only a minute and 40, we can watch it, I guess. Yeah, that's him by the looks of it, melting his aluminium.
Whoa. Scary. 10
Yeah,
minutes.
I think it's just like a cooking pot, and he's got an air compressor off hooked into it.
Wow.
Yeah.
So it's probably not something you should try at home unless you're a nutter. But there you go.
Well.
So fundamentally, casting is pouring hot stuff into a cavity, guys.
Well, if you think about it, when you make ice cubes, that is effectively casting water into ice cubes. That's a stupid example, I know, but that cast didn't exactly. Yeah, actually, what did it? Oh, it went all right. It's not the best.
But there you go. But fundamentally, that's casting for you. It's really.
I suppose I should give him a proper shout out. This is David Cambridge. If any of you want to have a look at some of his weird and wacky products videos that he's made doing various different things, and I shall switch back to me. Hello.
Awesome. Okay, so there's there's so many ways of casting stuff that we won't go into it right now. Most commonly seen. So this is an LCT AKM. The front sight block, gas tube, gas thing, front trunnion, rear trunnion, and some of the internal stuff inside the receiver are all cast. You can see from the texture on the casting that's what they've done. I don't know what casting process they've used, but these parts are definitely cast. They're cast on a lot of US real AKs, and that's why they're all failing. So that's another issue as well.
Well, yeah, because originally the AK was CNC, so not CNC but milled.
Milled.
The AK-47 was actually a milled gun. So really, the majority of AKs that people say are 47s are actually AKMs, which were stamped steel.
Oh, don't get me going.
Oh,
that's a whole
another video.
That's a whole other video, that one. So that's really common for stuff like that. Front sight blocks. Basically, if it's made of, there's a lot of stuff on ARs, so M16s, M4s, where the front sights and stuff will be die cast. But when it's things like if it's made of steel, it will be cast with a slightly more primitive technique. These are pretty good actually. They finish really nicely.
I wonder, like ACOGs and stuff. What do you think?
Airsoft
clothes.
There'll be die casting.
Yeah.
Cool. So let's whiz on. Hot liquid poured into a cavity mould, left to cool, part removed when cool enough. Normally needs some post processing. So if it needs to be dimensionally accurate at any point, you stick it in a mill, which we'll get onto a bit later. Problems. So if you do a turbulent pour, if you get a load of bubbles in your pour, you can end up with bubbles inside your mould, unless you have good mould design. You can retain those bubbles unless the mould is designed well.
And I think that's what happened with my mate's first attempt.
Yeah, there's ways of doing it with bleed offs and traps and bubble traps and all sorts of stuff. It often has quite a poor surface finish, which needs post processing, and it has a comparatively weak, uneven grain structure. So as it cools, it grows crystals and it grows a grain, and that grain is not necessarily aligned very well with the part. But generally, for airsoft terms, if it's non-structural part and it's made of a decent material, it should be fine. Okay, so what we're going to come on to now is forging. Forging is super rare in airsoft. There are some, you can get some forged receivers for various bits and bobs. Forging is a big industrial, scary process. And
we've had a small-scale demo of it already on this video with your intro video.
Yes, so forging is also a technology which goes back to the dawn of time, because fundamentally it's hitting metal with hammers. And that can be on an anvil, or in a really high tech factory, or with great big massive presses. For airsoft parts, it's very rarely used. There are some high end upgrade bits where you see it, but it's worth talking about. And I think there's hopefully more and more stuff coming in. GHK's forged. GHK are doing the forged slide Glock 17, which we're quite excited about.
Really?
It's now been delayed.
Of course.
Yeah, but that's going to be
expensive.
So yes, and I don't care.
Yeah, no, exactly. It's going to be good.
It's going to be built like the real one. Just a bit of an aside, but the slide's also got overmolded. They've overmolded the steel frame. So one thing you can do with injection molding is you can put things into the tooling, like thread inserts or steel rails, and then the plastic is molded around it, and it comes out as one integral unit. So they've got an overmolded steel rails in it and all sorts of things.
So G36 is the same process. The actual G36 is they put the barrel and trunnion in and then mould around it, I think. So the barrel is then moulded into the upper receiver of the G36. Okay,
Gaz has said VFC makes some forged gas blowback rifles. Yeah.
Oh, right, okay.
Yeah, there are some forged stuff. And the GHK Glock is actually cheap, I agree. It's pretty much made like a real one. Okay, so let's have a quick look. That picture that's now on screen is an actual AR lower receiver, you get it's relatively expensive for proper tooling. You get very strong, consistent parts. If you need some accuracy, you tend to have to post machine it to get those to get the reference bits correct. There are many different methods. We can talk about press die forging. I'll attempt to get a video up for you of forging, just try and explain it a bit more, because it's quite exciting, really.
So by the looks of it, that AR receiver is a solid part that then is mounted into jigs and CNC machined down to give it the tolerance. So it's why the AR platform itself is quite an expensive rifle, and that's why the AR-18, AR-180 came about, because we'll talk about stamping later, but it was a stamped steel body to make it cheaper.
So this is press forging. It's often done in different stages, so the part is slowly stretched until you get a blank, which you can see the centre of the screen coming in, and then it's stretched over a number of different stages into the shape. If you do it in one, it will split or it will rupture. So this one has you can see the three bits of tooling coming down, and the amount of cooling needed. So this is a serious machine, a serious bit of kit. You need a furnace, you need a multi-stage press, you need cooling. This is why when people say the AK is a really cheap, easy thing to manufacture, then they try and do it. Actually, it's not. You need really, individually they may be inexpensive, but you need massive infrastructure.
Yeah.
In order for it to actually work. So it's very difficult.
I mean, there's all those people but that dude made an AK out of a spade. And it's like, yeah, he made some of an AK out of a spade. He didn't make the barrel and the bolt assembly and the pressure bearing parts and the sights out of the spade. He made maybe the receiver, and the stock. That was it. I
mean, I'd love to see more forged parts. It is expensive. So there's kind of three ways of doing. You get cold, warm, and hot forging. Hot forging is pretty much, it's gone past its transition temperature, so it really is pretty much molten. Warm is it's around its kind of crystallization temperature. That's where the metal kind of forms its crystals, and cold is relatively cold. It moves down a series of increasingly more accurate complex dies. So you've got a complex part. Some forgings you can do in one hit. Generally, you need to do it in several different hits in order to get it to just like a blacksmith can't whack a part out in one whack. You need to stretch the metal over time. It can be very heavily automated. You can kind of whack things or press them, and again, you need press machining needed for accuracy. The picture I've got on screen, guys and girls, is a cross section through a forged part, and you can see the grain structure, which we're going to go into next because it's quite important. Forging can be very expensive, therefore it's very rarely used for airsoft. It's really not easy to set up and run. Once you've got a forging press running, you want it to run as often, and a lot of these processes you want them to run as often as possible, and just keep running. Once your setup can often be one of the most expensive parts.
Oh yeah, absolutely.
And again, accurate parts can be. We keep coming back to this, but for accuracy, generally you need to post machine stuff, which is expensive. Right. So before we get into the nitty gritty, which is basically I'm going to do a little bit on grain structure and crystallization of metals, because it's quite important for airsoft and manufacturing in general, and it's also why things break a lot, because the stresses and the strains that the part is subjected to, the way the part has been designed and the way it's manufactured doesn't reflect the strains that it goes under. One of the most, and this happens in real guns. One of the most common breaks in an airsoft AR is right where this pin is, because there's a hole straight through there, and this is a relatively stressed part of the gun, and also it gets dropped, and they tend to crack. Right across here. It's very common, and it happens in the real ones, but obviously less so because they're made of forged aluminium and not out of some awful pot metal.
Yeah. The other one to me that I've seen break a lot are classic Army MP5s, metal bodies, because they've got two little tabs that come forward that hold the barrel assembling the kind of the front end of the MP5 onto the receiver, and then lo and behold they just snap, and you can see the grain inside. Yeah.
Okay, so back to the presentation. Okay, so metal has a crystal structure. So when it cools, it grows crystals, just like salt or anything else. It grows crystals, and it also has a grain like a wood, and that's the grain tends to come in during the manufacturing. And so if it's put through a big mill, when steel's molten and put into big ingot and rolled out, it will form a grain structure like wood, and the crystals will align in the direction that it's made. Generally, casting is worse than CNC, and CNC is worse than forging. If you're really high tech, if you want to get aerospace guys doing jet turbine blades are completely mental. And they can grow a jet turbine blade out of a single crystal. So it's just, and also that stuff is mind-blowingly industrial secrets. Yeah.
I know whenever you watch how it's made on Rolls-Royce engines, they'll be like, and then they go and grow a blade, and here it is.
We're not telling you about how it was. Well, they grow a blade, and then they blow. It's absolutely bonkers. Okay, so on screen in a minute, Ben, will be 3 pictures of the same part I had up in the forging structure. I think you should be able to see it just about now.
Yep.
Okay, so I've got forging, machining, and casting, and the green lines pretty much represent the grain and pretty much the crystal growth as well within the part. And you can see with the forging, the crystal structure and the grain of the metal. This is why forging is so strong. As it's been progressively whacked with the hammers or put in the presses, the grain structure follows the outline of the material itself. This is obviously grossly oversimplified, but you can see very much pretty much how it works. So obviously and if you do it, and depending on how they do it, so they can progressively create the part using those presses and those and those big machines. What this will do is mean that when the load comes on the part, they've aligned that crystal growth with the load on the part as it comes on. It's really very clever. Machining. So this is a kind of reductive technique. It cuts material away. The grain structure, like you see the vertical lines, because that's the way it's come out of. That's how the steel's been created. It's been put between big rollers and it's been pushed out. So when you machine stuff, you cut through the grain. Yeah. Okay. It's almost like I've just had an analogy I'll use in a minute. Casting, because it's poured in, there's loads of little eddies. It's like if you look at a rock in a stream, there's loads of eddies and turbulence around it. And that happens in casting as well. Again, good design can mitigate that, and they can control the flow through the mould, but you still get an element of this. So the crystal structure and the grain of the material isn't aligned with the load on the part. So cast parts just tend to be a bit more brittle, and that turbulent flow can cause problems inside the mould as well. It's pretty much why you get bubbles in BBs.
Yeah.
Okay. So forging is, it's a bit like if you grow a tree in a certain shape, it's going to be a lot stronger. So when they were building wooden warships, they were training trees and tying trees in certain shapes to form parts of wooden warships and ships in general. If you have to cut apart, it's much weaker. And we all know if you use a bit of wood in the wrong place, it just splits. And it's very similar for almost engineering materials as well. So forging is better than machining, is better than casting. And again, but then the cost goes up as well at the same time.
Absolutely.
Okay, so we're getting there. Actually, we're rattling through. If anyone has any questions, put them in the comments, and we'll try and answer them at the end.
The recurring question on Facebook is either what kind of wizardry is it that we can watch on both streams at once, and am I sad for watching it on both streams at once? I
should say, actually, Graham Hoffman from Airsoft Nation very kindly provided me with an account which allows us to simultaneously stream on Facebook and YouTube, which I'm really, really grateful for. So thank you, Graham. I really appreciate that.
Yeah.
It's brilliant. Thank you very much. Okay, so we shall move on to, let's press the button. Stamping. So that's not throwing a tantrum. Effectively, it takes sheet metal, and so quite thin sheets of metal, and makes it into a shape. You can blank. Blanking is effectively cutting. Yeah, so the stamped Ben's, I'll show you. They can't see it just at the moment, Ben, because I've got the presentation up. But if you bring it up in a minute,
yep.
You can blank, which is cutting out. Bend, you can draw, which is you take material and stretch it into it, and you can emboss. And again, this is one of those things that's done in multiple stages, so you don't do it all at once because it just wouldn't work. You need to kind of tease it into shape. It's relatively cheap-ish for large quantities. As you add complexity and accuracy, that adds cost and difficulty. So let's go back to Ben. Ben, if you hold your AATV up.
And as you're saying, cheap, and that's why the British government chose stamping for their service rifle.
And we talked about it earlier as well. With the original AR-15 is a complex gun. It uses expensive manufacturing techniques, and Stoner and his team did the AR-18, which then eventually got bullpupped into the L85, because it's an easier technology for not poorer nations, but nations which aren't willing to spend that much money on firearms to access. And stamping is super common. It's all over the place.
Ironically, I think the L85 worked out more expensive per rifle than an M16 at the end of the kind of A2 saga.
And again, so this is bring the LCT AKM up. The receiver on this is stamped. And then it's got parts added and riveted into it. Stamping done well is quite expensive, and again but once you've got the infrastructure in place, it's relatively cheap. Again, it's used mostly in airsoft in AKs and L85s, but it's a very common thing. You can also do massive parts, so half of a car can be stamped and all sorts of bits and bobs, and the sterling and all sorts of stuff. Yeah. Okay. Let's see if I can run another video just to
try and think if there are any other major stamped guns out there. Type 89s maybe. Is it Type 89s? Galils as well might be stamped.
Yeah. So this is a multi-part stamping. So you get the sheet metal rolling along, and there's like 4 or 5 different stamps making the parts. Again, you can draw it. So that's taking a flat sheet and turning it into a dish. People's washing machines, people's cars, backs of tellies. It's a fridges. It's a super common. But again, it's expensive. Although you can do it on quite a small you can do it on quite a small scale relatively cheaply. LCT started off I believe LCT themselves started off making washing machine parts and bits for cars and stuff like that. This part on screen at the moment you can see it going through the multi die process, so it's done in several stages. LCT themselves started off making bits for cars and bits for washing machines. Then they were pretty much the OEM for Inokotsu, and then they decided to go do it themselves. So you don't necessarily need massive machines to do stamping. If you use a lot of manual, there's a lot of manual work, you can do it relatively cheaply. Certainly to do it on a big scale is quite expensive. And as we say, as the Gaz says, Ben, the Type 89 is basically just an AR-18 made under license. The Type 89 is basically just an AR-18 made under license in Japan.
Yeah. At least they paid for their license.
So stamping you can do relatively cheaply, but you end up using a lot of labour.
Yeah.
Obviously, when you industrialise it, it gets more and more expensive.
Yeah. I'm assuming a stamping tool, it's not too hard to change like the cutting head and the stamp head to go from making one part to another part. Because effectively it is just closing down with pressure onto a sheet of metal.
So you can see there's a massive stamping plant there at the moment.
Yeah.
So this is doing kind of car bonnets and bits and bobs.
Yeah.
So absolutely huge. Really very common. It's a good process. To get it really accurate, expensive. For airsoft, doesn't really need to be that accurate, so we can get away with it. LCT do a very good job with their stampings. They're really solid. And we're nearly there.
Yeah.
You lucky people. Let's have a look.
Tons of time.
CNC.
CNC.
So computer numeric control. Effectively, it's the automation of machining processes. So milling, lathing, cutting, sawing, plasma cutters. In airsoft, it's normally done in metal. You can CNC. We used to get prototypes made of stuff in plastic. So if we're doing a plastic case, they'd actually CNC the entire case for us, which was pretty mental. It's a relatively expensive process per item. So the setup's quite expensive, and every time you run one, there's no massive cost benefit for running a lot. You still pay a lot, as we'll talk about in a minute with your project, Ben. You still pay a lot. And the costs vary massively on complexity and finish. It's all about machine time, effectively. It's how long does that part need to spend in the machine.
Yeah.
And how long. So, machining processes have been going on for a very long time. Automation.
Oh.
So, drilling, milling. I'll put a video on in a minute, but effectively, you can drill holes, you can cut away parts, you can do all sorts of stuff with CNC control on this, and also it's often used at the end of another process. On this, there's lots of CNC that's been done to this rail at the front. They've produced it using another method, which we'll touch on in a minute, and then a lot of the slots have been CNC through. It's partly why a lot of people moved away from Picatinny, because the amount of work needed to post-process one of these rails is enormous, because they need to machine all of these slots away and then drill all the little holes in the rail. You can see all the little holes in the underside here all have to be drilled independently.
Yeah, it is quite a complex process, but if you were doing that, it wouldn't be too hard to do if it was a 5-axis CNC.
And I'll show you a 5-axis cutter in a minute on the video. So you've got a CNC project of your own, Ben. Do you want to talk about that for a little bit?
So I am making this, which is currently a 3D printed rail. We're making them in metal, and they are being CNC'd. However, because it is entirely being done in the UK, and it's being CNC'd, so it's already quite an expensive process to begin with. It is quite an expensive project in general. And we've had to make some compromises to make it work and to try and reduce the cost of manufacture. So the real one, I believe, the process H&K do will be extrude the length of the rail and then finish that off by putting that into a 5-axis and milling. Whereas we're trying to save the cost by making it in 2 halves, which are then joined together and then finished. Because then that way you can make it in 4 machine moves, because you can do both sides on each half and then join it together.
Yeah.
And then I think it might be an additional one to go and just do the final rad, because it's obviously a nice curved design and they have to mount it flush first. But But yeah, that's the process. We start off with 2 billets of aluminium, and then remove material from it until you're left with the final product, which I can probably pull up a image of.
Yep. Yeah, do that. That'd be great. I've got a video ready to go with the 5-axis machine. So what we're talking when we're talking about axis, we're talking about the ways the machine can access the part. So a normal miller has a big drill which basically comes down and spins and takes material out. That can go up and down. It can go back and forward. Big fingers, Ben. And it can go left and right. With a 5-axis miller, the part can also rotate underneath, and the part can also flip. So the part can move, rotate that way, it can rotate that way, as well as the drill head doing its movements as well. And I'll show you a video in a little second.
Instagram wouldn't load for some reason. I'm heading to my other reliable source.
If you get it queued up, I'll just play this video for the guys, and then they can guys and girls, and then they can see what we're kind of talking about, because this is quite a cool part. So this is a milling machine, 5-axis milling machine that's running at the moment, and you can see the way the part can rotate, the part can move, and as well as the milling head cutting bits of material away.
Oh, so, I know this video.
This is the V8. This is a V8 engine block that they made.
Yeah. Oh, what's the company? Is it like Tiny CNC or something?
Something like that. These guys are amazing. They make absolutely amazing things. So this.
What? Well, we're trying to convince our bosses to let us buy one of these for work, even though this would barely be used by us, but we just want one to play with.
So that's the interesting bit there. You can see just in a second you'll see the part rotate.
So yeah, it's a cross between a mill and a lathe, effectively.
I don't know what's happened there. Anyway, so that's the process. So basically, there's basically a big drill cutting away machine. You can change and also these more modern machines can they change the drill head and they change all sorts of stuff. What you about to play, Ben?
I've got some clips of the manufacturing prototype.
Oh, there we go.
Oh, why go away? There you go. So yeah, all CNC made, and you can see this was actually before they finished it. So that rail section is flat where they need to round it and radius just these last couple of corners here. So you can see the process. But also the reason we went for the split in two is so you could do the internal milling.
Yeah.
Because H key and my clone of E key, or inspired by, is based on having a recess for it to sink in and lock. Where are we? So yeah, it's got a recess to be able to actually lock your rail into, so it indexes back whenever you take the rail off and put it back in. But obviously you need to be able to machine inside, and it would be really expensive to try and do that in a one part.
Oh, it's an ad. So I'm just getting adverts on my... adverts on my video.
Thanks,
right. Thanks, YouTube. I'm trying to do a cool present. Here we go.
Oh, there we go. Oh, the Fusion 360 advert. Good bit of software, that.
So CNC fundamentally, you can create, depending on how complex a cutter machine you're using, you can get fairly complex parts. It's mostly used in airsoft for finishing off other bits.
Yeah.
And making sure that it's dimensionally, ideally making sure it's dimensionally accurate. A lot of the time they don't; they just bang die castings together, and as we talked about earlier, bang in a self-tapping screw and hope for the best. And then you realise, then you can't shim your gearbox properly because the holes aren't aligned effectively and everything else.
So you sent me a link a couple of weeks ago for that using was it a Loctite to center bearings with a special kit.
Yeah.
Because cases aren't that accurate.
Yeah, trying to get. I think a lot of problems people have with shimming and teching is the holes the bearings go into aren't parallel with each other. They're not they're not actually in line, and the gears are the gears might be at a bit of an angle. Just playing this video, Ben, because it's really cool. It's like right. Let's stop. Let's go back to here. Yeah. So So CNC on this. Obviously, this Vortex site's got quite a lot of CNC on it as well. CNC, certainly there's this rail, which would be expensive separately. It's got an awful lot of. So it would have been extruded, which is just about to go onto, and then CNC machined. So generally, good CNC is expensive. It's not a cheap. It's really not a cheap process. There aren't massive cost savings when you start getting into lots of items, and the costs go up massively with complexity and finish. Okay, so the last one we're going to go into is extrusion. This is used for making great big long fixed cross-sectioned linear objects. So I have an good example here, and it's off. And just as Ben talked about, the where you'll see it most often in airsoft is rails. So your railed handguards. This has a cross section consistently all the way down. You can see it here. So this has been extruded, and then it's had some post-processing CNC done to it. Now, part of the reason M-Lock is really popular is it needs very little machining operation, because you can just put a cutter straight in and go zzz, and then put it out. So it makes a lot making these slots is an awful lot easier than making this rail.
Yeah, and that's why you have Keymod and Airsoft Keymod, because Keymod has an internal recess like H key.
Yeah.
To help lock it in and locate it, whereas Airsoft Keymod is just straight in, do the hole, do the nub.
But apparently this isn't M-Lock, this is N-Lock, because it's a new prol, and they decided to make their own standard.
Right.
Yeah.
I think. Oh, is M-Lock? I think M-Lock's got a bevel on it, so it's a tool in at an angle and then at an angle, whereas probably N-Lock is just straight in. Straight in
and make a big hole. So extrusion. Effectively, if you've ever seen videos of pasta, you have one of those weird Play-Doh machines when you were a kid, and you squeeze and you put a weird little die on, and it squeezed holes out.
Yeah,
that's pretty much what you do with aluminium. It's and generally extrusion is most of the stuff will be done with aluminium. You do it's soft and malleable enough that you can. It's quite crazy the amount of pressure you need to squeeze an aluminium. And they do it.
Have you seen stainless steel being extruded?
That must be nuts. The tooling for that must be absolutely horrendous.
But what's really cool, the one I've seen, is it's for boat parts, for like rails on the side of boats, and it'll come out, and then they'll be diverting the flow, so it'll actually form the correct shape as well as it comes out. And it's absolutely insane. I can't imagine to think how much it costs.
So I'm just going to put a 3D graphic up. This is another animation from YouTube. So I've been plunging YouTube, and it will show you how it's done. It's again, this is one of those big, phenomenally expensive industrial processes. You can do it on the cheap, but if you do it on the cheap, it tends to go badly wrong, and things warp, things don't fit very well. You don't get very consistent wall sections. So a lot of the stuff we've been talking about, and I'll talk over the top as this is playing. A lot of the reason airsoft stuff doesn't change very much is because a lot of the tooling is extremely expensive. So people go, well, why haven't Marui made? Why do people keep cranking out AR-15s? It's because they've already got the tools for AR-15s, and they can keep making variants on AR-15s or M4s or M16s relatively cheaply, just with a few changes. Whereas to create a whole new gun, if it's not something like a not very complex stamping, it's extremely expensive to start off. And also, it used to be a bit easier with injection molding. So when Marui used to injection mold stuff, that tooling was relatively, I find it was expensive, but they could do it. Whereas when we start talking about tooling for metals and those processes, it gets vastly more expensive. So you basically see, this stuff is pretty much squeezed out like spaghetti.
Yeah.
And then they clamp on to cut off the crap bit. And then a clamp comes in onto the good bit and then helps it by pulling it along, because this stuff can be 200 metres long in some plants. And they start moving along. So again, this is partly why good rails are expensive, because this tooling is expensive, and it's why a lot of rails will look like every other rail, because one person will pay for the tooling, and that'll be that bit of aluminium tubing, shaped aluminium tubing, will then be sold to every other manufacturer in order to offset the cost. So that's why everything. So you can start to see why there's not a lot of variation. You see a lot of parts which are very similar to other people's parts. There may be differences in how they're finished off or how they're post-processed or what the surface finish is or what the paint is. But a lot of the time, what we're actually talking about is the parts probably came from the same couple of factories, because that tooling is really expensive, and it's how you deal with that.
Yeah, absolutely.
And you might change things like the cycle time. You might change things like the material that goes into the mould and how you finish off that mould. But that's pretty much how it works. Really, it's all very It's expensive. It's really very, very expensive. Stamping is probably one of the cheapest ways of doing it. If you're going to do it in the Far East and use lots of manual labour, then it's not too bad. But certainly, proper good die casting mould is expensive, and you need a return on investment.
Yeah, which, to be fair, with kind of like little known and fairly unique guns, is quite unlikely, because if you think about it, airsoft isn't actually that big of a industry.
Right, it's really not.
It really isn't. We think of it as being a massive thing because there's all these brands and stuff, but it really isn't. Like the number of sales, I wonder what per year the number of airsoft replica sales are.
I was talking to Ben Webb about this on our presentation last week. So I used to work for Games Workshop, which is a medium-sized British company, turns over about £300 million a year. And I know what some airsoft companies do, and it is a tiny, tiny fraction of that.
Yeah.
So a lot of airsoft companies will be turning over $1 million, $5 million, $10 million, but that's not a lot of money when you start paying for £100,000 tooling.
Oh yeah, absolutely.
And £500,000 tooling. It's really not a lot of cash.
So I wonder if a lot of that kind of initial kickoff, and when you see kind of a gun come in, you're like, hang on, why are they making that? If it's because it's been a request from, say, I don't know, a military for training aids, and they've got the money to fund them to do that initial run.
I think that's why that's why they did the TM Type 89. I always wonder if that was actually a Japanese military.
Yeah. Well, that's where I started. It was a training aid. It was for the Japanese Defence Force.
Well, if anyone's got any questions on manufacturing processes or anything else, jump in the comments as we're drawing to an end now. So if you've got any questions you want to ask or anything, let us know. Me and Ben will carry on waffling for a couple of minutes, and we'll see how we go on. Yeah, so absolutely, it's one of those things, isn't it? And when Systema did the PTW, I think that was marketed a lot to militaries and law enforcement.
Yeah. And it's the same with what's the
GBLS?
GBLS,
yeah.
And there's that American equivalent that hasn't come out yet. Was it American Airsoft or something?
Yeah, and KWA are heavily marketing into law enforcement certainly in the States. KWA USA are really marketing into law enforcement as a training aid. Yeah,
and I've heard that supposedly the British Army have a load of airsoft L85 sitting about that they sometimes use, although I've never heard of them being used before. So whether or not that's a bunch of
there are some people using airsoft guns because it's cheaper. It's cheaper than running simunition and safer to a certain extent as well. It's interesting. I find it all very fascinating, and you wonder why, but to make really nice stuff, for Marie to go to a forged receiver, that's going to cost, that's money.
Yeah,
that's
proper. But then again, you pay that because Tokyo Marie recoils are a kind of peg above everything else.
Yeah, but this is still a die-cast nickel receiver.
Oh, that's true. That is very true.
You know, it's that's why they break a lot.
Yeah.
So you're paying a lot of money, but again, there's a load of one of those things. So if we want, I think one of the things to finish on is that if we want innovation and we want exciting new guns and we want exciting new materials, and someone makes one, we need to buy them.
Yeah, absolutely.
Because otherwise, no one's going to take a risk. That's why Games Workshop make a load of Space Marines.
Because everyone buys Space Marines. And it's why all airsoft manufacturers make ARs, because everyone buys ARs.
Well, everyone says they want a gas Scar, some weird ass 1957 Swiss rifle.
Mm-hmm.
But then they make it, and then the three people that said they'd actually buy it don't buy it. It's just not going to happen.
Yeah.
People are going to. These things are expensive. Tooling is expensive. It's I think what we've tried to show and talk about in this live stream is that manufacturing things is really difficult and it's really expensive, and to do it well is really expensive. So that's why these companies don't take a risk. That's why there's New Prol make 27,000 variations of their Delta, because they need to get that return on the mould costs. And why everyone else makes, because they've already got that, they've already got the expensive bit, they've got that tooling done, and then they can bolt stuff onto it. That's just
absolutely.
That's just the way it's going to work.
Yeah. And that's why as soon as G&G release their Lee Enfield, I'm jumping on it, because I know it won't stay around that long if no one buys it.
Yeah, they'll stop making it. There's plenty of airsoft guns that have gone because they're just not economic to produce.
Yeah, they stopped making their P90 for a while. They stopped making the FM2000. Oh, hang on. They stopped making their FM products for a while. The other one, King Arms, basically died off for 5-10 years and then have started coming back. But King Arms SLR, that was out for, I think, a year run and then another year run in like 2005, maybe 2012. Because, sure, loads of people want an SLR, but then who actually wants to step up and pay that kind of fee for it?
Well, I would pay an awful lot of money for a machined or forged steel receiver.
Oh yeah,
SLR. But I'm pretty sure I'm in the vast minority when it comes of airsoft players.
Oh, yeah.
I know a lot of people that'd be very happy to pay a lot of money for one. But the 10 people that I know, I'm not sure. I'm not convinced that's enough people to make it economically viable. I mean, VFC have just done one, so let's all. And when that gets released, and when hopefully LCT. Yeah, you're right, Gaz. New Prol did go to another OEM and then decided to tell me that they owned the moulds, which was hilarious. I did find it quite funny.
Oh dear. Oh.
Yeah, it's always good. It's always good when you know about Far East manufacturing and someone's trying to tell you about Far East manufacturing.
Yeah.
Yeah. So it's one of those things. Okay. Ben, give a quick check on Facebook, and just because I'm not getting Facebook comments through on the stream, and just check if there's any questions.
No, nothing on Facebook.
Great. Okay, guys. Thanks for
one viewer. And it's probably we got two now.
It's probably me. So thanks for joining us again. It's been a lot of fun for me and for Ben. If you like this sort of thing, we'll do another one on kind of OEM and QC, which is kind of a bit more niche. But I find quite interesting with an engineering background. Thanks for joining us. This will be up on YouTube for future reference. Ben, where can we find you?
You can find me at my Facebook page, English Kiwi Airsoft, or you can find me on YouTube at English Kiwi.
And are you on the Instagrams?
I am on the Instagram as well, and that again is English Kiwi Airsoft. Just English Kiwi.
Great, and obviously you're already watching me, so I'm not going to tell you where to find me. Great, thank you very much. And,
thank you very much for having me on, Tom.
Absolute pleasure again, and we'll see you guys next time.
See you soon.